So today we will continue with the determinants. Okay. So I think all of you know what is a determinant, and you know how to find for the determinant of by 2 matrix, right? AD minus BC. That's fine. This is a 2 by 2 matrix, and the notation. Okay, notation that denotes the determinant is 2 straight lines. Okay, 2 straight lines here. See, this is not a bracket. Okay, this is a straight line. Okay, so with the straight lines, it means we want to find the determinant of that matrix. Okay, so for 2 by 2 matrix, the formula is AD minus BC. Okay, AD minus BC. And this applies only to 2 by 2 matrix. This AD minus BC, okay, is applied only to 2 by 2 matrix. Okay, for a 3 by 3 matrix, okay, there's one shortcut. Okay, maybe some of you learned this before by copying the first 2 columns and you put it at the back. Then you use the 3 straight lines minus another 3 straight lines. Okay, so actually this is same with this one. Okay, this is I will call this as shortcut. Okay, shortcut, because later you will see what is the general, okay, general method to find for the determinants of n by n matrix. Okay, n by n. No matter 2 by 2, 3 by 3, 4 by 4, 5 by 5, and above, we can use this. Okay, but now we look at the shortcut way for 3 by 3 matrix first. Okay, so this one, okay, we will follow this direction first. Okay, this direction. So 3 in a group, A, E, I. So A times E times I. Okay, A, E, I. And then this 2, okay, this one, BF. BF, we will group BF with this G. Okay, this one, BF, we group with G. There must be 3 in a group. So B times F times G. And this one, DH, we will group it with C. Okay, so D times H times C, this one, DHC. And you sum them up, okay, you will get one sum. Okay, then minus another direction, this direction. Okay, so CEG, one group, BDI, one group, FHA, one group. Then you get this. Okay, the first sum minus the second sum. Okay, this one, I think I show you one example first. So let's say let's say 1, 2, -1, 0, 3, 2, -2, 1, -3. Okay, let's say this one. Okay, so we want to find for the determinant. Okay, we use this, we follow this direction first. Okay, this direction. So 1 times 3 times -3. Okay, you get a negative, I'm sorry, -9. Get a -9. Okay, this 3, one group. And this 2, we group it with this. Okay, this 2, we group it with this. So plus 2, -2. And this 2 group with this. So 0, 1, -1. 0, 1, -1. So this one you have to sum this up. Then minus another direction. Okay, this direction. So you have to remember this direction first. Okay, just like the AD minus BC. AD minus BC is also start from this direction. Okay, so this direction we have -1, 3, -2, 1. We have to sum up the 3 groups. So this 2, 1 with 1. and 0, 2 with -3. So the first sum, you have -9 minus 8 plus 0 minus 6 plus 2 plus 0. So when you sum this up, okay, then minus this one, you will get the determinant. -17 minus 8 -25. Okay, so this is the determinant of this matrix. So I repeat, okay, I repeat. When you want to compute for the determinant, make sure this is not bracket. Bracket means a matrix. Okay, these two lines means this is equals to the determinant. Okay, the determinant. So this direction first, 3 in a group. You find the product and then plus these two with this one. Okay, and plus this two with this one. Okay, you get this two. Okay, no matter which one first, you can take this 1, 2, 3 or this 1, 2, 3. Okay, no matter which one comes first. Okay, you will get the same answer. And then minus the other direction, 3 in a group. And these two with this. These two with this. Okay, this is actually same with the, maybe some of you learned this method before, where you have this 1, 2, 1, 2, -1, 0, 3, 2, -2, 1, -3. Then you mark, you copy another 2 lines, 2, 3, 1. So this one, this one, this one is this 3. Minus another direction, 1, 2, 3, which is this 3. Actually, they are the same. The difference is this one you don't have to write this 2. Okay, you don't have to write this 2 out. Just look at this, and you know this 2 with this 2 with this. Okay, they are the same. Okay, but it's up to you. It's up to you. If you feel that this is more comfortable or more confident for you to compute, you can use this. Okay. Okay, now we continue to the general one. Any questions for this? No. Okay, now we look at this method number 2. Okay, method number 2, this is determinants by using cofactor expansion. Okay, cofactor expansion. Okay, so determinant of an n by n matrix A is denoted by this one. Okay, this 2 straight line means determinant of matrix A, and it is computed by, okay, there are 2 ways. Okay, you have 2 choices to compute a determinant by using this cofactor expansion. 2 choices. One is along a row, or another one along the column. Meaning that you can choose any row. Okay, from the matrix you can choose any row or any of the columns to carry out this computation of cofactor expansion. Okay, any one will do. You will get the same answer no matter which one you choose. Okay, so this is the formula. Now we look at this one first. Summation. You know what is a summation? Summation. Sum xi. Let's say I is 1 up to 3. This one, symbol of summation, it means when it starts from I equals to 1, we have x1. Okay, x1. Because of the summation, it means it is a plus. Next one, I equals to 2, so x2 plus x3, and we stop here because I start from 1 up to 3. So this is the expansion from the summation. This is what it means. Okay, summation. Okay, actually, we have another one, the multiplication, x1 times x2 times x3. That one, you can see this, like maybe in next subject, I equals to 1. Okay, the big pi. Okay, big pi, xi, that means x1, x2, x3. This is for multiplication. Okay, summation for sum. Okay, so if you look at this, okay, this one means when j is 1, you substitute j is 1, 1, 1 here, okay, up to n. Okay, so if you have 3 by 3 matrix, n is 3. Okay, and what is the value of I? Okay, I depends on the row. Okay, this is along a row. It depends on the row that you choose. If you choose the first row, I is 1. If you choose the second row, I is 2. Okay, and so on. Okay, so similar to this, to the one along a column. Okay, the formula is similar. Okay, now we look at what is the items. Okay, the components inside the summation. Okay, so you see this 1, 2, 3. These 3 components. Okay, the first one is the alternating sign. Okay, -1 to the power of a value. So the value, if the value is even number, you get positive 1. If the value, the I plus 1 value is odd number, you get -1. So it's either +1 or -1. So this one, we call this as alternating signs. Okay, it will be alternate, plus, minus, plus, minus. Okay, same goes to this one. Okay, Aij, A, the lowercase of A. Lowercase of A refers to the entries of the matrix. Okay, the entries of the matrix, A11, A12, A13. That is lowercase of A. Okay, and uppercase of M, this one, Mij. Okay, M is known as minor. Okay, now we look at what is the minor. Minor of a matrix Mij. Okay, of an n by n matrix is the determinant of n-1 by n-1. So meaning that if your matrix is a 3 by 3 matrix, then the minor will be 2 by 2 matrix determinant. Okay, I repeat, if your matrix is a 3 by 3 matrix, then the minor will be the determinant of 2 by 2 because n-1, n-1. Okay, for example, you are given this matrix A. Now we want to find the minor of 3, 2. So first of all, you have to identify where is the location of the 3, 2. 3, 2 means row number 3, columns number 2. So this is the one, right? This is the location. Now we want to find the minor of this location. Okay, so to get this, you just remove the row and column that contains this. So we remove this one, we remove this one. So what is left? 2, 3, 6, 8. Here. See the 2, 3, 6, 8. And the minor is the determinant of the matrix left. Okay, so this is a 2 by 2 matrix. So the determinant will be AD minus BC. That's why you get a -2. Okay, so this is a minor. So if let's say now I want you to find for minor, let's say 1, 3. What is the minor of 1, 3? You can try. Minor of 1, 3. One, 3, the entry of 1, 3 is the number 3, right? Okay, the number 3. So number 3, this is the one. Okay, this one, we remove this one and this one. So what is left is 6, 5, -4, 7. 6, 5, -4, 7. And give a determinant. Okay. So AD minus BC. Okay, be careful with the plus and minus sign. 22 minus -20. So you get a 62. Okay, so this is minor. Okay, remember minor, we will identify the location of the entry and we remove the row and column that contains that entry. And what is left, we compute the determinant. That would be your minor. Okay, so if 2 by 2, sorry, 2, M22, M22, M22 is this one, 5, right? So you remove this and this. So what do you have? 2, 3, -4, and 1. 2, 3, -4, and 1. So AD minus BC, which is 14. Come again? Is it possible? For 2 by 2 matrix. 2 by 2 matrix. Then you will get just one value. You just get one value. That one I never tried before. What's the try? This minor is used to find for the determinant later. Find for the determinant. Okay, this one can try later. Okay. Okay, so minor is one of the components. Okay, so up to this moment, you know what is this entry, you know how to get the minor, and this one, this is alternating sign. Okay, this alternating sign is the sign assigned at the location. It has nothing to do with the plus minus sign from the entry. Okay, nothing to do with the minus sign from the entry. The alternating sign is this one. The first location, the sign is plus. The alternating sign is plus. For this location, it will be minus. Okay, there are alternating signs. So plus, minus, plus, minus. So this one, plus, minus, plus, minus. So if this is minus, it will be minus, plus, minus, plus. Okay, this is the sign for the location. Okay, nothing to do with this one. Okay, so if we say that the alternating sign for this location, so what is the alternating sign for this location? Plus or minus? Minus, because plus, minus, plus, minus. Okay, that is the alternating sign. Okay, so now we have one more new term, which is called as cofactor. Okay, cofactor denoted by A. Okay, cofactor, this is the formula. So what we need is just the alternating sign multiplied to the minor. Okay, for example, this one. We want to find for the cofactor of 2, 1. Okay, so cofactor of 2, 1. 2, 1, that means row number 2, columns number 1. This is the one. Okay, so this one. So the alternating sign for this location is minus. So that's why you have a -1 here. Okay, and this is cofactor. Cofactor is the alternating sign multiplied to the minor. So we have to find the minor for this. So we remove this row and this column. So we have -1, 3, 7, 1 for the minor. Okay, so AD minus BC. Okay, you will get -22. -22 multiplied to -1, you get a +22. Okay, so this is the cofactor of 2, 1. Okay, so 1, 3, same goes to 1, 3. 1, 3 is the first row, the third column. Okay, that's mean this one. So this one, the alternating sign is plus. Okay, if this location, the alternating sign, it will always be plus, starting from plus. So plus, minus, plus. So the alternating sign for that location is a plus. So +1. Okay, and for the minor of this location, we remove this one and this one. So we have this. Okay, AD minus BC, you get a 62. 62 times +1, you get 62. Okay, so this is cofactor. Okay, any questions? Okay. Okay, now we look at the next one, how to find the determinant of a matrix by using cofactor expansion. Okay, remember, this is your formula to get the determinant of A. This is your formula. Okay, we need to have these three components. Alternating sign multiplied to the entry multiplied to the minor. Okay, so now this one, let's say I choose the first row. I choose the first row to compute for the determinant. Okay, I choose this. Okay, so this row, the alternating sign for this one is plus, plus, minus, plus, right? So you have a plus, minus, plus. Okay, and the second one is the entry. We need to multiply the alternating sign to the entry itself. So the entry is 2, -1, and 3. So you have this 2, -1, and 3. Okay, because of the summation, that's why we have this 3. Okay, we find it one by one. Okay, the first one, alternating sign is plus. The entry itself is 2. The minor of this location is, we remove this 2. We have 5081 here. This is the minor. And then we have to plus because of the summation. Okay, plus the next entry location, alternating sign plus minus, so minus, and the entry itself -1, and the minor for this location, remove, 70, -2, 1. Okay, and then plus, because of the summation, we use plus. Okay, for this one, alternating sign is plus. The entry itself is 3. And the minor for this location is, okay, remove this one. Okay, so you just compute and you sum up, you get 215. Okay, so now if let's say I don't want to use the first row, I want to use the second column. Okay, second column here. Okay, so we will use this 3. Okay, so the alternating sign for this location is minus. So we have a minus here, minus, and then the entry itself, -1, multiply to the minor, remove. So we have 70, -2, 1. Okay, and then plus. Okay, alternating sign for this location, plus. So plus, okay, plus, no affection to the value, and then the entry itself 5. Then multiply to the minor. Okay, remove. We have 2, 3, -2, and 1. Okay. Okay, and then plus again. The alternating sign of this is minus. That's why you have a minus here. Okay. And then 8 is the entry itself. And then remove this 2. You have 2, 3, 7, 0 for the minor. Okay, so when you compute, you will get the same answer. So no matter which row or which column you choose to compute for the determinant, you will get the same answer. Okay, so based on this, which row or which column should we choose? Yeah, you can choose any. But if you want to have an easier computation, which row or which column would you tend to choose? Row number 1. Any other choice? Row number 2. Which one would you choose? If you are asked to compute the determinant of this matrix by using core factor extension, which row or which column would you choose? Yeah? Row 3. Why row 3? It means I would choose either second row or third column. You see why? You see why now? When you have a 0 entry, when you have 0 entry, that's why you don't have to calculate for this. So we will tend to choose the row of columns that contains zeros. Yes. Okay. The next one, we will look at how to find the determinants through some theorems. okay, through some theorems. Okay, theorem 1. If A is a triangular matrix, okay, a triangular matrix, it means it's either upper triangular or lower triangular. Okay, upper triangular means the upper, okay, the upper part is non-zero. Okay, the lower part is all zeros. Okay, so this is called upper triangular because the non-zero value, the non-zero entries are stay at the upper part. Okay, and the lower triangular means the upper part is all zero. Okay, not including the diagonal entries. This is the diagonal entries. Okay, so when you see an upper or lower triangular and you need to find for the determinant, this is the formula. Okay, we just need to find the product of the diagonal entries, and that will be your determinant. Okay, so this one you just 1 times 3 times 2 times 1, then this is the determinant. Okay, so the criteria is it must be a triangular matrix. Okay, no matter upper or lower, you do the same. Just take the diagonal entries and you find the product. Okay, so this is theorem 1. Okay. But if you use the four-factor expansion, the way, the method that you learned just now, this one, okay, you can apply that one to find the determinants for this 4x4 matrix. Okay, you will get the same answer with this. Okay, so this is considered a shortcut to get the determinant. So whenever we see this, we know, okay, just find the product of the diagonal entries, we get it. Okay, next one, this one. Okay, theorem number 2, this is related to the row reduction operation. Okay, this one, I think maybe some of you learned how to, you learn the Gauss elimination. Gauss elimination. Okay, for those who have learned Gauss elimination, you should know this. Okay, this one, you will learn this more in details in next chapter. So now I just roughly introduce this. Okay, I just roughly introduce this. Okay, so there are 3 parts for row operation, row reduction operation. Okay, the first one is we can swap 2 rows. Okay, we can swap 2 rows of the matrix. So this one, 1, 2, we swap with 2, 3. Okay, and sorry, this is not swap. Swap is here. Okay, the second one. Okay, the second one. Okay, we swap the row 1 with row 2. Row 1 with row 2, we swap. So the row 2 will be row 1. Row 1 will be row 2. And no changes for row 3. So whenever we apply this operation, this is called interchange. Okay, interchange between 2 rows. When we apply this operation, the determinant of the matrix, it will change in such a way you will get a negative. Okay, whenever you swap 2 rows, you get 1 extra negative. Okay, meaning that, okay, for this matrix, let's say for this matrix, the determinant is 5. Let's say the determinant is 5. And after you swap these 2 rows, the determinant of the this matrix, it will be negative 5. Okay, after you do the swapping of 2 rows, the determinant of the new matrix, okay, will have an extra negative sign. If you swap row 2 and row 2 and row 3 again, and then you will get the same determinant as this, because minus minus you get a plus. Okay, and the first one, this one, we can multiply any constant to one of the row and we plus to another row. Okay, this is a command. Okay, negative 2R1 plus R2, meaning that row 1, all entries from row 1 will be multiplied by negative 2. So this one times negative 2, we get negative 2. And then plus to row 2. So negative 2 plus 2, you get 0. Okay, and the first row, this one first row times 2 times -2. So 2 times -2, you get -4. -4 plus 3, you get -1. Okay, so if we reduce the matrix by using this, okay, basically there's no changes in the determinant. Okay, no changes in the determinant. The determinant of this matrix is still equals to the determinant of the new matrix. Okay, this is row operation. Okay, row operation. Okay, C. C is if we factorize, okay, any of the row. Factorize any of the row. For example, this is the original matrix. We factorize 3 from row 2. Okay, factorize 3 from row 2. So we have 1 and 2 here. 1 and 2. But the value that we factorize, it will be here. Even though we just factorize from one row. Okay. So you see the determinant will be changed into 3 times the determinant of this new matrix. Okay, and another example here. Okay, let's say we factorize 2 from the row 1. Factorize 2, you have 1, 6 here, 1, 6. So we have a 2 here. And we found that, okay, we can further factorize 3 from this column. Okay, so we factorize 3 so that you have 2, 1 here, 2, 1. So the 3 is here. So 2 times 3 times the determinant of this. One, we want to use this row operation to find for the determinant. Because when you have a very huge order of matrix, it is impossible for you to use the cofactor expansion. So this way will be the choice, okay, to find for the determinant of a matrix with a big order, okay, 10 by 10 matrix. Because in our real life, the matrix order is more than what you can think of, okay, in real life problem. It could be thousand over thousand, it could be million over million, okay. So this is one of the way to get the determinant, okay. But if you are not clear with what is this, how to get this, don't worry at this stage, because we will look at this once again in chapter 2 in more in details. And by that time, I will make sure you know how to get this, how to find for the new matrix. But at this moment, what I want to introduce is, if you use this way to row reduce the matrix, there's no changes on the determinant. If you swap the row, you will get one extra negative sign. If you factorize the any of the row or columns, okay, you will get the values here. The value multiplied to the determinant of the new matrix. Okay, that's what you need to know. Okay, and theorem number 3. Okay, if A is an n by n matrix, so after you transpose the matrix, there is no changes on the determinant. The determinant, you see, this matrix after we change into A transpose. So 1, 2, 3 is here, 4, 5, 6 is here, 7, 8, 9 is here. Okay, so basically you see there's no changes on the determinant. The determinant of the transpose matrix is still same as the determinant of the original matrix. Okay, this one. Okay, next. Theorem number 4. If 2 columns of the matrix, 2 columns of 2 rows are equal, okay, same exactly, you see 1, 1, 2, 1. This is also 1, 1, 2, 1. So the determinant will be 0. It will be 0. Okay, this one got to do with the theorem number 2 just now. Okay, you see, these 2 rows are same exactly 1, 0, 1, 0, 1, 0, 1, 0. So automatically it is 0 for the determinant. Okay. Next one, theorem number 5. If any of the column or any of the row consists entirely of zeros, all zeros. Okay, all zeros, no matter row or column, the determinant is 0. Okay, this one you can relate to the cofactor expansion. If you want to compute the determinant of this, we will choose this second column, right? All entries 0, that means all components 0. We sum out all 0, we get 0. Right? Okay, theorem number 6. Okay, if A and B are n by n matrix, square matrices, then determinant of the product of AB will be equals to the determinant of the two matrices separately. Okay, you can find the determinant of A and B separately, and then you multiply them together. You will get it is the same as this. Okay, as this. This is you find the product of AB first, then you find for the determinant. Okay, these two are equal. Okay. The next one, if A is a square matrix, then A is invertible or non-singular matrix. Okay, non-singular matrix. Or matrix, we can try to find for the inverse matrix if the matrix is non-singular. Okay, non-singular. Non-singular means the determinant is non-zero. Okay, non-zero. So if the determinant is 0, we call the matrix as singular matrix. Singular matrix has no inverse. Okay, it has no inverse. Why? I show you this one first. This is the formula to get the inverse matrix. What's happened if your determinant is 0? You get 1 over 0, which is undefined. We can't have 1 over 0. So if your determinant is 0, this means no inverse. Okay, if your determinant is 0, we call that matrix as singular matrix. So singular matrix has no inverse. Okay. Okay, in general, this one is not equals to this. Okay. This one is not equals to this. Okay, so these are the theorems regarding to the determinants. Okay, now we come to this exercise 1.3. Okay, evaluate the following determinants. Okay, this one, you can try to use the shortcut or theorems or whatever you know, okay, to evaluate this. Okay, now look at this matrix. Which method would you choose? Triangular matrix. The theorem of the triangular matrix, because this is 0. Okay, so the fastest way for number 1 is the theorem of the triangular matrix. So you just find for the product of the diagonal entries. Okay, 5 times -2 times 4. Then you get the determinant. Okay, triangular matrix. Okay, number 2. Number 2, which method will you choose? This is the 4 by 4 matrix. Which method would you choose to compute for the determinant? Can't use shortcut. Shortcut is for second, for 2 by 2 and 3 by 3. So you have only theorems and the cofactor expansion. Okay. So according to the theory, this is not a triangular matrix, and we don't find any 2 rows or 2 columns which are same exactly, and we don't see any or 0 rows or columns. So you have to use cofactor expansion. Okay, unless you know how to row reduce the matrix. Okay, if you know how to row reduce, then you can use the theorem number 2 to get the answer. Okay, but since maybe now some of the students you haven't learned about that one, so I won't show that. I will just use the cofactor expansion. Cofactor expansion, which row or which column would you choose? Which one? Row 4 or column 4. Okay, either this one or this one. Okay, so now let's say I choose this. You can also try to use the column number 4, then we check our answer. Okay, let's say I use this. Okay, so 0, 0, this one. The only non-zero is this. So the alternating sign, plus, minus, plus, minus, plus, minus. This is the alternating sign. This is the entry. And we have a minor. This is a 4 by 4 matrix. So the minor for the 4 by 4 matrix will be 3 by 3. It will be 3 by 3. So you remove this and this. You have 4, 2, 0, 2, 0, 0, 3, 0, 1. Okay. So this minor is in 3 by 3. So you can use the shortcut way to compute for the 3 by 3. Okay, determinant. The answer is 4. The answer is 4. Is that minus? Okay, for those who didn't get the answer, look at here. Okay, this direction first, 0, 0, right? And 0, so 0. Minus another direction, 0. This is also 0. This is 4. Okay, for those who have done number 2, okay, proceed to number 3. Number 3, use the core factor extension across third column. Third column. Third column.
Then we got it. I said, one meeting.
Okay, coincidentally, it's 0. Okay, coincidentally. Okay, do you get the answer? Okay, next we are familiar to compute the determinant of 3 by 3 matrix. Okay, normally please one include this population of this 3 by 3 matrix because it will be used to compute for inverse of matrix. To compute inverse of matrix, you need this. Okay, any problem? Any questions for this question number 3? Okay. You have to keep the practice, okay, the practice, try to complete this kind of 3 by 3 matrix. So we have to Okay, done. For those who have done, you can look at question number 4. This have to use apply the theorem number 2.
Yes.
Okay, now we move on to question number 4. Okay, you are given the matrix A, B, C, F, G, H, I, where the determinant is 7. Okay, you are given this info, and you are asked to find the determinant of this matrix. Okay, so we have to make use the given info. So you need to change the matrix A into the original matrix. Okay, into the original matrix. So what we do? You need to factorize, right? You need to factorize 3 from the raw 2. When you factorize the 3 will be here. So you have A, B, C, D, E, F, G, H, I. But this is same exactly as the given one, and the determinant is 7. Okay, because we have to use the given info. Okay, this one, I give you the command, okay, of the operation negative R2 plus R1. Okay, negative R2 plus R1, it means we multiply a minus into the row number 2. Okay, row number 2, we multiply a minus, so this will be negative D. Negative D and then plus to row 1. So negative D plus to row 1, you get. Okay, this one times negative 1. So you have negative D. Negative D plus to this one. So this will be equals to A. Okay, so negative E plus this. You get B. Okay, negative. This is F, sorry. Okay, negative F plus this, you get C. Okay, so no changes on this D, E, F, G, H, I. Okay, so if you use this, is there any changes to the determinant according to the theorem? No, no changes. So 7. So determinant of this is 7. Okay, number 5. Number 5, you can use any method. You want to use shortcut, you want to use cofactor expansion, it's up to you. So you know how to compute the determinant of 3 by 3 matrix. Okay, and we continue. We have one last subtopic. Okay, inverse of a matrix. Okay, as what I explained just now, for a matrix to have an inverse matrix, the matrix determinant must be non-zero. Okay, it must be non-zero. Okay. This is the formula for the inverse matrix. Okay, this is the formula. So we have 1 over determinant multiplied to the adjoint of A. Okay, this is the adjoint matrix of A. Okay, for those who haven't done the exercise just now, okay, you can complete it at your growth. Okay, look at here now, because normally from the past experience, quiz 1 got to do with the inverse of a matrix. Okay, that's mean this topic. Okay. For this semester, I'm not sure, but for the last few SEM, the question is on from this topic. Okay. Okay, so this one, okay, we have to find for the determinant first, make sure it is non-zero, then we proceed to get for the adjoint A. Okay, adjoint A. Okay, now we go straight to the example. Let's say you are given this matrix A, we want to find the inverse matrix of A. Okay, so the step 1 will be we find for the determinant first. Okay, if this determinant is non-zero, so we will proceed to get the adjoint A. So what is the matrix of adjoint A? What is the transpose of cofactor matrix? Okay, transpose, you see this one, transpose of cofactor matrix. Okay, cofactor matrix is the matrix that contains cofactors. Remember what you learned just now, cofactor, which is denoted by the uppercase of A. The uppercase of A is the alternating sign multiplied to the minor, right? Alternating sign multiplied to the minor. So at this position, okay, this one, I'll show you this one. I copy this one to that page. This one. Here. Say this one. Okay, so this is matrix A. The cofactor matrix at this position, okay, at this position is this one. Okay, this is the cofactor at this position. So cofactor means we have to know what is the alternating sign. Okay, so you can put the alternating sign first for each of the location. So we know that it will be start from plus, so plus, minus, plus, plus, minus, plus, minus, plus, minus. You put the alternating sign first, And then for each of the entries, find for the minor. So for this position A, for this position, okay, entry 3, remove this and this, you have this 620 -3. Yeah. And at this position, remove this one, you have 521 -3. Yeah. Okay, so same goes to this one, you have 5610. Okay, so you do the same procedure to every single entries, then you will get the cofactor matrix. Okay, so next one, okay, you have to compute, okay, you have to compute AD minus BC. But because of the alternating sign, most of the times students commit mistake, careless mistakes here. Okay, let's say AD minus BC, we get a negative, but the student forgot to multiply the negative here. Okay, so what I recommend, okay, is you maintain the plus minus sign first. Okay, the alternating sign you maintain first. You just compute for the AD minus BC, put that into the bracket. Then only you simplify. Okay. Then last step will be find for the transpose. Okay, row into column, row into column, row into column. So this is your adjoint A. Okay, then finally put them into the formula. 1 over the determinant is negative 94 just now, and this is your adjoint. Okay, and after you substitute, you multiply this 1 over negative 94 into this matrix. This is the final answer. Okay, but actually you can leave it here. Okay, you can stop here. Okay, this is also the inverse of the matrix A. Okay, so I repeat once again. To get an inverse of matrix, first of all, find for the determinant first. If determinant is non-zero, then only we proceed. If the determinant is 0, you give a conclusion that this matrix A is a singular matrix. So there is no inverse. Okay, since this is non-zero, so we proceed to get the adjoint A. So the adjoint A is a transpose matrix of cofactor. Okay, transpose matrix of cofactor matrix. So the cofactor matrix is made up from alternating sign with minor. Okay, alternating sign with minor. So you can put the alternating sign first. Okay, and then construct this. Then get the minor one by one. Okay, form all this. Then, okay, the plus minus will remain first. Compute the AD minus BC from each of this. Then you simplify the sign. Then find for the transpose matrix and put these two into the formula. Then you will get an inverse matrix. Okay, now we look at exercise. Okay, exercise. Okay, AD minus BC. This is a 2 by 2 matrix. AD 20 minus AD minus BC 20. Okay, equals to 0. Okay, so there is no inverse for matrix A. Okay, find for the determinant. AD minus BC.
Yeah, because.
Okay, for 2 by 2 matrix, the formula for 2 by 2 matrix is this one. I write it here. Okay, for 2 by 2 matrix, let's say A is A, B, C, D. Then A inverse will be 1 over determinant of A, and then we swap this B and A, and then we change the sign of B and C. This is the formula for the 2 by 2 matrix to get the inverse. Okay, so determinant -5 minus 6, we get -11. So the B inverse is 1 over -11. So we swap the 5 and -1 and change the sign of 2 and 3. So that's why you get a -5 over 11, 2 over 11, 3 over 11, 1 over 11. Okay, number 3. Matrix C. Okay, 1, 3, 1, -1, 1, 1, 4, -2. Okay, find for the determinant first. you can have a big bracket and do like this one first, in case you forgot about the alternative sign. And do not forget about the transpose. Start with first. Some students they forgot to insert the alternative sign. Okay, then only you fill out the values. Okay, find the reminder. The adjoint C is a transpose matrix. Do not forget about the transpose. Otherwise, you will skip the step and get the wrong answer.
Yeah.
Okay, then transpose the matrix and put the adjoint C and determinant C into the formula, then you will get this answer. Okay. Okay, any questions? Okay. Set the answers is or this one. Acceptable. Okay, so for question number 4, I leave it to you to have a try on your own because final answer is already given here. You can check. Okay, so please try. Okay, please try. Take this as the exercise. That's it. Okay, and you can also start the tutorial questions under the big one. Okay, this is the final answer. Okay, so we stop the class here and I will see you next week.